Okay, we are still looking at regression lines and residuals, right? So we can tell if an equation is appropriate by looking at the residual plot. So we're going to give in this data, and we're going to do two different types of regressions. Our first one is a linear regression. So I'm going to pause this and put this equations, all this data, into my calculator. Okay, I have put my data into my calculator and I ran a linear regression, and this is what my calculator says. So here is the slope of my linear regression line, and here is the y-intercept. Now looking at the r squared at 0.02, this is probably not going to be a very good equation to model my data. Okay, but that's exactly what we want to talk about today when we're looking at our residuals, is our data. So we're going to write this here. I want you to write this equation. Y equals negative 0.357 x plus 16.333. So we are being asked next to do our predicted value. Okay, so the predicted value is what your calculator says when you plug in your given value. So I'm going to plug 2 into my equation that my calculator gave me. And then I'm going to plug 4 into my equation that my calculator gave me. And then I'm going to plug 6 into my equation that my calculator gave me. And I'm going to calculate all of my predicted values, the ones that are coming from the equation that your calculator gave you. So this is what my calculator gave me, right? I plugged in a 2 for x, a 4 for x, a 6 for x, an 8 for x, y, a 10. And then these are all of my calculated y values. Okay, so using my linear equation, these are going to be the y values that I get. So I wrote them all down right there. Okay, now the residual is, of course, your given value minus your predicted value. So 5 minus 15.619, 15 minus 14, 26 minus, 23 minus, 11 minus, 3 minus. Okay? Now, I don't want you to do that per se. We're going to let our calculator handle all of those. So let's see where it is on our calculator that we can find all of those values. The residuals are all represented here in this box of your calculator. It says resid, and then it gives you, well, all of them right here. So we have 1, 2, 3, 4, 5, 6 residual numbers, because we only had 6 calculations. Okay, so we're going to write this down in your residual value box. We're going to write all 6 of them. This is in order. So this is for 2, and then for 4, and then for 6, and for 8, for 10, and for 12. So now we're going to plot those on our residual grid. Okay, we're going to take a look at what they look like. So remember, these are 2, 4, 6, 8, and 10. So those are going to be your X labels, 2, 4, 6, 8, 10, and 12. Looks like we have more lines than we need. And we have to decide, how do we want to partition our Y values? So I have a largest Y value of 11, right? That's my residual of 11, and a biggest one of negative 10. So what if I make each of these lines 3? So 3, 6, 9, 12 in the positive, negative 3, negative 6, negative 9, negative 12 in the negative, right? So you get to decide, since there aren't any values here, how do you want to partition or label your axes? So this is how I've chosen to label my axis, right? Based upon our Y values, right? Because we want to get them all on the screen or on your plot. So I'm going to plot each of these, and we're going to come back and see what that looks like. So there is our plot of our residuals. And what we want to see is, does there look like there's a pattern? And looking at it, it kind of looks like there's like a negative a negative quadratic pattern to that residual. Okay, so let's look at what else we can see. Well, I'm going to take a picture of the graph and show you guys that. So here are my points plotted, and then this is my linear regression line that came out of my data. And as you can see, it's not very good, right? It doesn't go through very many points at all. Some of them are below, and then above, and then below, right? This is why we have that quadratic looking regression line. It's because of the differences in between the actual values and your predicted values, right? That's what your residual is anyway. It's this, the distance in between your actual values and your predicted values. So these are all of your residuals. This is how we calculate it in the first place. Okay, so in other words, this regression line is not a very good fit. So let's go back and let's look at the quadratic one. Okay, so here is our quadratic regression that I get from my calculator. So here is your x squared term, here is your numeric term, and here is your, this is your x, and that's your constant term. Okay, so we're going to come over here and we're going to write that above our quadratic regression table. Right, on this part, we're going to write y equals, it is negative 0.81 x squared plus 11. We'll call it 1x minus 14. Squeeze it in there, minus 14. Okay, I believe that's 14, or 13.999, which is pretty much 14. So we'll leave it as 14. And here are all of your residual values. So we're going to write this on our residual value spot on the table, and then we'll come back and we'll do the predicted values. We'll calculate those in a second. But while we have our calculator handy, let's write down all of our residual values. Okay, there's all of your residuals, right, from your calculator. Now let's use the calculate thing and our equation. We're going to plug this into our calculator, and we're going to get all of the y values that are predicted now. So there are all of your predicted values, right? We use the equation that we came up with from your regression line, and we replaced x both places with a 2, and then with a 4, and then with a 6, and then with an 8, and then 10, and a 12. And these became all of the predicted values from your quadratic regression equation. Okay, they're not the actual values. The actual values are, of course, come from your data, right? And so we're looking at what's the difference between the calculated value and your actual value. So now we're going to plot these residuals, these blue residuals, okay, for your quadratic. We're going to plot it here on this grid, and we're going to see if there's a pattern to it or not. So there's a plot of my residuals. So if I were to connect these, right, we don't see any smooth looking pattern. This is a pretty random distribution of residuals, which means our equation is pretty appropriate. Right? We can talk about the appropriateness of our equation based upon these residuals. So the quadratic is much more appropriate than your linear, right? Because there's not a pattern to your quadratic, where there is a pattern to your linear. So this one would be a not appropriate, and your quadratic would be appropriate. Okay, so yes, this is more than what you're usually asked to do. You really aren't asked to find the predicted values, but you're using the equation from your calculator, and you're plugging in your x's, so you have to actually do some calculations. So let's look at the way that this one looks. Hang on one second. So here is a plot of my data, and then a plot of the regression line that the calculator used to create all those residuals. So as you see, some of the values are exactly there, some of them are below, a couple of them are above, right, and then below and then above. This is exactly what you want to see if we have a appropriate equation, right? Some of your values are below, then the next ones are above. Above and below means that your regression line kind of goes through the middle, right, of your values, which would make for a pretty decent looking regression line. Okay, so that's how we use a residual to decide if our equation that we got was appropriate for our data. Okay, go forth and be awesome.